Hello everyone, today we will start the topic reactions involving COOH group. So in the carboxylic acid, the reactions which involve COOH group we will study. So first reaction is reduction reaction. So in reduction reaction, the carboxylic acid will convert into primary alcohol. So what will we add? So you are taking carboxylic acid and you can add lithium aluminium hydride or your diborane B2H6 in the presence of ether, and secondly you add H3O plus, and what will you get? You will get your primary alcohol. So this is the first reaction, that is reduction reaction that involves the COH group. The second reaction is decarboxylation. So in decarboxylation, what happens? Your CO2 is removed from the carboxylic acid. So the first reaction is when you add soda lime, that is NaOH and CaO. So you have to take sodium salt of carboxylic acid, RCONA, and when you add soda lime, that is NaOH and CaO, soda lime, sodium hydroxide and calcium oxide in the ratio what? 3:1. So this is in the 3:1 ratio, and you heat it. Then what will you get? The CO2 will be removed and you will get your alkane, right? And Na2CO3, right? So this is the reaction in which decarboxylation occurs, that is CO2 is removed from your reactant. The next reaction is Kolbe electrolysis reaction. What happens in that reaction? You take the alkali salt of carboxylic acid, like sodium salt of carboxylic acid, and add water and then do electrolysis. So you do electrolysis, and here also CO2 is removed, and what product you will get? You will get double the number of carbon atoms in the alkane as present in the reactant. So you will get RR, you will get CO2, you will get hydrogen H2, and you will get NaOH. So this is the Kolbe electrolysis reaction, right? So this is also a name reaction, and here also the CO2 is removed. That is why it is known as decarboxylation reaction, in which aqueous solution of your salt of carboxylic acid is electrolyzed and you get alkane, in which there is double the number of carbon atoms as present in the reactant, and CO2 is removed, hydrogen is removed, and another byproduct is sodium hydroxide. So these were decarboxylation reaction. Next reactions are halogenation reaction and other substitution reaction. So let us see that. So next reaction is substitution reaction, in which what happens that if you take carboxylic acid having alpha hydrogen atom. So let us take carboxylic acid having alpha hydrogen atom. So this has alpha hydrogen atom, and when you treat it with what? Halogen X2 in the presence of red phosphorus, and then add water to it, then what will you get? You will get your product as alpha halocarboxylic acid. So here alpha, at the alpha carbon atom your halogen atom will be substituted and you will get product like this. So this halogen can be bromine or chlorine. Now this is a name reaction which is called as Hell-Volhard-Zelinsky reaction. So this is the substitution reaction, or the halogenation reaction. In substitution reaction, this is halogenation reaction. The next reaction is what? Ring substitution. So in ring substitution, the aromatic carboxylic acid, what they do, the carboxylic acid is what? It is deactivating group and meta-directing group. So the incoming electrophile will get attached to the meta position of the aromatic ring. Let us see how. So if you take the aromatic carboxylic acid and do the electrophilic substitution, that is, if you add concentrated HNO3 plus concentrated H2SO4, then your nitro group will attach to the meta position, because COH is deactivating group. So you will get meta substituted carboxylic acid, right? Similarly, if you do bromination, you add Br2 in the presence of FeBr3, then your bromine will get attached to what? Meta position. So this is how ring substitution occurs. Now the aromatic carboxylic acid, they do not undergo Friedel-Crafts reaction because this carboxylic group is deactivating. So your Lewis acid will get attached to the carboxylic acid group. So this was all about today, and in now your chapter aldehyde, ketones and carboxylic acid is now complete. So I hope you have understood this chapter. Thank you. We will meet in next lecture.